In experiment A14, the idea in experiment A14 is to use continuous monitoring methods to deduce rates of reaction. By continuous monitoring methods, we need something like this piece of apparatus here, the gas syringe, where we could take measurements at different points in time, continuously running the same experiment, as opposed to an initial rates method, where you might take one data point and that's it for that experiment. So this is a continuous monitoring method. What we've got here then in the conical flask is 20 grams of small marble chips. So that's going into that conical flask like so. Sorry, 10 grams of small marble chips going into that conical flask like so. In a moment then I'm going to add to that 20 centimetres cubed of 0.5 molar hydrochloric acid to the flask. Replace the bung really quickly and watch what happens to that volume of carbon dioxide over a course of time, so over about 3 minutes. Okay. Importantly, the gas syringe has a fixed capacity, and if we exceed that capacity, then the barrel comes all the way out and it can fly off and smash or what have you. So if this gets to 100 centimetres cubed, I might as well take that out in any case, take the bung out, because I can't measure anymore. So if it gets to 100, we'll stop the experiment. All right, here goes then. So let's just get zoomed in nicely so that I'm then ready to pour this in, put the bung on and get started. This is a second example of monitoring rate of reaction by continuous monitoring. So in this example, instead of a gas syringe with a scale, there's a measuring cylinder here with a scale on it. So the instructions say to add about 10 grams of small marble chips to the sidearm tube, that's this thing here. So I'm going to pop those straight into there like so. And then to add 20 centimetres cubed of 1.0 moles per decimetre cubed hydrochloric acid and replace the bung really quickly. So I shall do that now. So put that straight in there like so, stick the bung on it like that. Okay, so the next thing to notice is that this starts to bubble and the bubbles go straight into this measuring cylinder. Now at the moment it's a huge measuring cylinder and I need to wait until this reaches the scale. So I'm going to start the stopwatch at the point at which I can measure this accurately. So the first recording at time 0 is going to be at 26 centimetres cubed of gas collected. So I'm going to keep my eye on this now, and that's there. So that was time 0, the stopwatch is now going. Now I'm going to measure every 10 seconds. So at 10 seconds, the volume is 34 centimetres cubed. Watching continuously at 20 seconds, the volume was 39 centimetres cubed. Next reading will be at 30 seconds, and that's looking like 44 centimetres cubed. Next one is at 40 seconds, and that is 50 centimetres cubed, 50. I'm going to keep going every 10 seconds, so this next one's at 50 seconds, that's 54 centimetres cubed. Every 10 seconds until we get to 2 minutes is where I'm going. So this is 60 seconds, 58 centimetres cubed. 70 seconds, 62. 80 seconds, that was 66. 90 seconds, 70. 100 seconds, 73. 110 seconds, 76. 120 seconds is 79. And now I'm going to go every 30 seconds. So 2.5 minutes, 150 seconds will be the next reading. And that reading is 87 centimetres cubed, 87. The next reading will be at 180 seconds or 3 minutes. And that reading is 94. So the next reading at 210 seconds or 3.5 minutes. And that reading is 99 centimetres cubed. Next reading will be at 4 minutes, so that's 240 seconds. And that's 104 centimetres cubed. I think I'll do 1 more minute's worth. So we'll go 270 and 300 before we move on to the next stage. So 270 seconds is coming up. And that reading is 108 centimetres cubed. And the final reading I'll do at the moment will be at 5 minutes or 300 seconds. And that reading is 112 centimetres cubed. So now the next stage for this experiment is to leave that all assembled and leave that going until that bubbling stops, and to record the final volume of the hydrochloric acid, the final volume of the gas produced inside here. So we'll leave that running and we'll come back and see what the final volume is.